Okay, I've got that it's 1 o'clock. Maybe I have to get that clock up there a little bit tuned up. But today we're going to take a look at lesson 2 after we see if there's any questions from lesson 1. And I got some new software this morning that I'm trying out. It's only 20 bucks, so it's kind of cool. You can actually just write on your screen. So I played with it a little bit, but I'll be able to hopefully pull up like MathAS, right on top of the questions. I can actually save the pages. So not only will this be nice for the live streaming, but I'll save the pages at the end and then they can be printed out as notes. So we've got notes, live stream, hopefully all sorts of resources that you can use. Um, and again, I woke up at 5 this morning like I usually do, and I've been looking for this for a long time. It's called Ink2Go. Has anyone used something like that before? No? It's supposed to work with both a Mac and a Windows. It's worked pretty good with the Mac. In fact, it's one of the few softwares that I bought, and within 10 minutes of trying it out, I was almost ready to go ahead and pay the fee. But I figured, well, I got 15 days, might as well use them up, right? But we'll see how it works. So first of all, is there any questions from lesson 1? Yes.
The combination, when it does the points, it says like you combine them. It's giving you 2 points. It's like it would be. It's combining two of the. This is on the homework. That's why.
Okay. Good. Let's just pull it up and let's find it, and then yes, we will see what it is. That's.
It's on the lower half of the homework. It's combining. You have to combine 2 of the points together. I mean, it's like one whole point, but it's broken up, and so you're combining 2 points together.
Okay.
And we didn't cover that, so I was kind of like, okay, are we just adding them together?
MAT121. Oh, and I did find out this little welcome screen goes away if we're in student mode. So we're lesson 1 in the actual in the online homework. Okay.
It's combining points, or because you have to. It's a graph broken up, but it's broken up, and then you have to get the parts together, broken up parts together.
Do you remember what question number it was towards the end?
The bottom, yeah.
Okay, let's just.
It's combining points. Something about
practical domain.
It's a graph. It'll come up with a graph.
Okay. Let's see. Maybe it's before this. I'll bet you. Let's see, let's go to 35. Something like this.
Yeah, it's like that, but it has a graph and it's broken up into like 4 sections, and then it's asking to combine the graph points together.
Okay, let's see. Not that.
It's something like that, but the graph is broken up more angular and into 4 sections.
Okay, even more. Okay.
And that's why it's saying to combine the graph areas together.
Let's see.
It's like something like that, but it will be
even
combining those different jagged.
Okay, let's keep going. So it's not. Let's see, we got 29, 28, domain and range. Maybe it's probably the last one. Probably should have kept going because what that sounds like is a piecewise function. In fact, let me go to the very end. Don't have graphs here.
But I got confused because we didn't cover that part of class.
Right. It's actually, that would be a topic from actually Math 150. So Was it maybe on the quiz?
It was on the homework because that's what got me stumped. Because
Okay.
we went over the material and then when it said combine the points together to get this, the solution, I'm like, you didn't do that in class.
Right. Let's see.
I'll send you an email. I have to go through
Okay.
mine. I'll send it to
Yeah, find that, send me an email, and we'll take a look because it and just to put your mind at peace, that sounds like a one to stretch you because it's not something we actually do in this
Yeah.
content. It's called a piecewise function, and you will do it in Math 150. Although it's not that hard to kind of understand when it's explained out, so it's a good one for us to go over. But it also won't be on the test, so that sometimes takes the stress out. And sometimes those are a little hard to come up with. So anything, since we couldn't find that one, anything else that you had maybe some issues with or wanted to take a look at? Okay. So otherwise, then we'll go ahead and move into lesson 2. And yes.
The last ones, I remember, I think I didn't feel, I don't even remember now. But the last ones were a little bit.
Like 38, like stuff like this.
I think I stopped before that.
Okay.
I didn't. Oh, okay. The last one I did was.
30?
Oh, no. Oh, yeah, that wasn't so bad. I thought you said it was. So
Okay.
if we don't go through this, we go to the next topic, you said,
Right, right. And we can come back to these. I mean, it's not crucial. We'll be looking at lesson 2 today and on Wednesday. And there's always time afterwards. And if you find them later, my goal is probably about an hour of direct instruction with another whatever time we have left of time for you to interact one-on-one, get some tutoring, get some questions, take a break, whatever you need to do. But it's sort of what I find works good for me and mostly for students is to kind of sit down and just go through the material and then start working through it. Okay. So we'll come back to this Math AS stuff in a moment, but what I want to start with is, and the other thing is I'm going to use, I think this software will work really good for online office hours so that and I'll put some information. It looks like I'm going to use something called Hangouts. Has anybody used Hangouts? It's a Google product. You can download the app and use it from your smartphone or a computer. And it's basically a video calling, kind of like Skype or something else. But the nice thing is when I'm using that, I can share my screen. So if you called me in on that, I share my screen with you, which would be something like this. I can pull up Math AS. So if you have a question, you tell me 36 in Math AS, we pull it up, we look at it together, and I can also write on the screen anywhere I want to write and work it out for you. I can pull up a calculator, put it on the screen so you see exactly what I'm doing. So we're going to see if, in some ways, this might even work better than tutoring because then I'm not looking over your shoulder or you're not having to look over my shoulder. We kind of got this. So we'll see how this all works. And the part I like the best, I got lots of colors. Okay. So today's topic, and then I just get to sit here and I look like I'm being lazy, I guess, or something. But I'm thinking it might actually work better because as I finish a page, I'll just ask for a new page. If I need to go back, it's there. So I don't ever really have to erase the board. So today's topic in lesson 2, the first half of it is dealing with something called exponents. And this actually is something, if you took math 90 or 91, 92 previously, maybe a couple years ago, you would have had this topic in Math 91. The district curriculum committee decided it no longer belonged in 91 and it should be taught in 90 or 121. So that's why we're doing it now. So it may be a review for some of you. Others, maybe you didn't see it if you've taken it recently. So first of all, what is an exponent? Is that an exponent? No, that's multiplication. But let's take a step. What does multiplication mean 3 times 4? Three groups of 4 added together, or 4 groups of 3 added together. We could do it either way, right? So let's, so I don't have to write as much. Let's write it as 3 groups of 4 added together, which does give us 12. And some of us just memorized it, that 3 times 4 is 12, and that's what we go. But this also is, multiplication is a repeated way of doing addition. So this is going to help us with what if I wrote it like this and put the 4, made it smaller and higher. Now, is that an exponent? Yes. That's an exponent. So what does that exponent mean? 3 times itself 4 times. So it's similar to kind of this multiplication took a step back to addition. Exponents really is repeated multiplication, which is taking a step back. But in this case, the exponent tells us how many times we multiply, and we can't switch it around. 3 to the 4th is not the same thing as 4 to the 3rd, right? So these are different. So I think the first one is 81. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. 4 times 4 is 16. Times 4 more, 64. One of the few cubes I remembered because it's small enough. But don't ask me what 6 cubed is. I get to 5. 5 cubed is 125, and that's about it. Okay. So, but what we're going to do is we're doing this with variables. And what I wanted to get you started with is feeling what an exponent actually means. Because sometimes we get used to just plugging in on a calculator 3, raise it to the 4, and we get an answer, and that's all we think about it anymore. But when we start dealing with variables, to understand how it all works, we want to really understand what x to the 3rd really means. So what does x to the 3rd really mean? Good. X times itself 3 times. That's what we would call the expanded form. We're expanding it out. And I'll tell you what, if you just know this much about exponents, everything else will be very understandable. So this is how we're going to, when we're going to look at the properties of exponents, we're going to expand it out to what it means. And then it's almost going to be just fall right in place. Okay. What if I had 2x to the 3rd? What does that mean?
X times itself 3 times times 2.
Okay, so does the exponent apply to the 2? No, it doesn't. So it's still just sort of like 2 times x cubed, and then what is x cubed? It just expands out. Okay. So we'll see this when I just wanted you to get a preview to this as we start working through various examples. And what I'll do is I'll go into Math AS and I'll pull up the practice problems, and we'll work a few of those, but I want to get, I think it's 4 properties. It might be 5. We'll see. We'll count them after we got them out there. But from this, just this basics, we're going to be able to understand all the properties of exponents. There's one more thing before I go to the next step. And this is something that we need to understand about fractions. What if I have 5 divided by 5? What's that?
1.
Good. It's equal to 1. And maybe some of the ways we think about it is that the 5 in the top, when they divide out, they sort of cancel each other out. And I like doing it this way because then you see the 1. 5 divided by 5 is 1. what if I had 28 divided by 28? Still 1. Well, I'll just cancel this way. Okay, cancel. So let's take a look at this. What if I had x to the 4th over x to the 3rd? Okay, let's expand them out. And some of you probably know what it is and can think of it, and there's a property. But what's the top x to the 4th mean? Good. If you just remember that, that's the key to understanding all of this. And we'll build it up and we'll actually be able to do some very complicated stuff. And in the bottom, there's 3 x's, right? All multiplied. And it's, red's always a good color to cancel things. So what happens when I have x divided by x? They will cancel. And since this is multiplication, what's 1 times anything? Itself, right? So then the second set of x's cancel. The third set of x's cancel, and that's all now just 1 times x, which gives us x. Or 1x if you want, but that's all it is. Now, looking at the exponents, in fact, actually, this is x. What would be the exponent on this x since there's nothing there? Technically 1, good. But sometimes when you don't see something, you think maybe it's 0. But we'll explain why it's not 0 because something else happened. So good. There's 1x, so it's x to the 1 power, 1x. Very good. What's another way we could have gotten the exponent 1 from the numbers 4 and 3? Very good. And isn't that sort of what happened is the bottom, if you're looking at that, it's subtracted off the ones from the top. The bottom subtracts the top. So exactly, we could have just thought of this. Let's go with the screen. This also could have been thought of as x to the 4 minus 3. We could have just taken those exponents, subtracted them, ended up with x to the 1st. So that's our first property of exponents. When you're multiplying two of the same base, and I guess I didn't define, I usually like to just start using things before I start defining things. So let's define this. The x is something called the base. And the 3 up here, this power, is called the exponent, or the power. Okay. So when you, and this is important, we have to have the same base, because if it's not the same base, they can't be combined. But when we're, sorry, I jumped ahead of myself. Anyway, usually I do the other one first, but that's okay. Division, when we're dividing two things, we subtract. Okay, does that make sense? Well, it's actually the second property, but I covered it first. So I guess there's no, right? No harm, no foul. So we'll call it the first property. And then we'll come and do the second property, which is sometimes easier to understand. So what if I had x to the 4th times x to the 3rd? And again, we just kind of want to expand this. What would x to the 4th? Would it make sense? Right. So let's just do the visual. X to the 4th is 4 x's. Because this way I've taught it for years. And if you ever get into problems or you're not quite understanding it, you just expand it and it's almost like it falls right into place. So that's x to the 4th. And then the second one would be x to the 3rd. So there's 3 x's. Well, don't these parentheses, when we put them together, doesn't that just mean multiply? So doesn't it, couldn't we just count them all up, 7, or add 4 plus 3? Yeah, so that makes sense. And that's why we usually cover this one first. It's a little bit simpler, I guess. So I could think of this as x to the 4 plus 3, which will give us x to the 7. So that's another property. Maybe we'll call it the second property. When we multiply things with exponents, we add the exponents. Again, as long as they have the same base. Division is subtraction. Multiplication becomes addition. Two major ones. Let's see, number 3. What do you think would be our next one? How about an exponent to an exponent? So what? X to the 12. How did you get that? Okay, multiply. So basically, if you just think we're stepping down one level of operation. So an exponent one level down would be multiplication. So this is where we should multiply. But again, I want to do it visually so you can just see what's going on. So what does the exponent of the 4th mean? It means 4 copies of that, right? Multiplied. So it's x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd. And we could take a step back. When we're multiplying, we just have to add all these together. 3 plus 3 plus 3 plus 3 is 12. So and again, we could think of that simply, the quickest way probably to get there was to take 3 times 4 to get x to the 12. Very good. Third property. Fourth property. I'm going to kind of do this one a little backwards. X to the 3rd over x to the 5th. So now it may look like we've actually already done division. I mean, you know, so how could we get this? Applying maybe the first principle that we did over here. With subtract, right? Good. So here that so we could take x, and remember it was always take the top minus the bottom. So that gives us what? Negative 2. Which is correct, but does anyone understand what x to the negative 2 is? Not really. At least I don't. Sort of, I do because maybe I've worked on it, but it's one of those things that's not really intuitive. Is x to the negative 2, is that a negative number? Yeah, actually it's impossible for it to be a negative number because a square, when you square something, it will be there. The negative itself on the exponent doesn't make the number negative either. So we're going to talk about this. But the only way, it's kind of an abstract concept, but let's do it this way. And I'm going to change colors. Let's go to yellow-green. Let's do it with the expanded way. And this will help it make sense, right? So what do we have in the top? X to the 3rd, which is x times x times x. What do we have in the bottom? X to the 5th. So we have 5 x's all multiplied together. And then what's going to happen with the canceling? Top, those 2 x's cancel, that cancels, that cancels. So what's left? Where? Down in the basement, in the bottom. Good. So there's 2 x's down here. What's left in the top? Good. There's a 1 up there because when we cancel, we get a 1. So it's sort of there's nothing, but at the same time, there's that invisible 1. It's not a 0 because if we put 0, then the whole thing becomes 0, right? It is really a 1. It's 1 over x squared. Doesn't that intuitively make a little bit more sense than x to the minus 2? It does to me, at least. So it explains that the exponent is not going to make the number negative. And it gets us to think of what is really a negative. A negative, if you start thinking of negative numbers as opposites, a negative number is the opposite of a positive number. So if you think of a number line, right? Positive numbers are to the right, negative numbers are to the left. When we subtract, that's the opposite of addition. Addition is to bring things together, subtraction is to take things and separate them. And so when we look at this, these two here, because x to the minus 2, would you agree that that has to be the same thing as 1 over x squared? Because really, we came up with the same, these two different looking answers by applying two properties that we know, or at least we were pretty confident that they worked because they worked before. And so these two things that we got maybe in different ways with both rules of math, under the rules of math, they better be the same, or else math is like this junk stuff or fake stuff, whatever they're calling it these days, which it isn't. It really does work. So these have to be the same. Okay. So when you think of this negative exponent, what it's really saying is divide by x squared rather than multiply by x squared. So if you think of it as opposite, that's what it's going to be. And so with that in mind, what if I gave you 1 over x to the minus 3? How would you rewrite that with a positive exponent? It would just move up to the top. It would be x to the third in the top. So it would be x to the positive 3 up here. I'll put a 1 just to show you that I just kind of move it up. Yes?
Are you just multiplying by the reciprocal?
No, I'm not even doing that. I'm just magic. So this is math. Sort of. It's just moving it. And it's just sort of because of what that means. When I move a negative exponent from either the bottom to the top or the top to the bottom, it changes. Crossing over that fraction line changes its sign. So this is what I saw a book. This is the best explanation I've had. It calls this the elevator rule. So a lot of we're going to do a few things with negative exponents, but the book and Math AS, they like to have their answers as positive exponents. And so when we get to the end, all we have to do to make sure we have positive exponents is move whatever's a negative exponent either from the bottom to the top or the top to the bottom, and that will change its sign from negative to positive. Okay, so I'll look at this. So the two examples, notice if we had x to the negative 2, I'll put it over 1. We do the elevator ride, it moves to the bottom and simply becomes a positive 2. So either one of these two. Okay. So it kind of takes the mystery out of a negative, but I think probably if you're like me, the hardest part of understanding negative exponents is you're thinking of a negative number. And what does it mean to multiply a negative number of times? It just doesn't make sense. But what it means is to do the opposite of multiplication, which is division. So we're going to divide by x twice rather than multiply by x twice. Okay. Or down here, instead of dividing by x 3 times, we're going to multiply by x 3 times. So it just means do the opposite. Okay. So that's sort of our fourth rule of dealing with negative exponents. I just couldn't think of what I was talking about. There's one more rule. You could probably squeeze it in here. Let's see. So that all our rules are on one page, and then I'll put another page, and then we could save this. And And I'll be honest, I haven't saved a page yet, so I don't know if it'll work or not, but that's what's fun, just do things and let's see if they work out. Okay, so here's the last one. What if we had, so rule number 5, it's too dark? Too dark? Okay, good. Thanks for that. So that's probably what they were saying at home, those who are watching the live feed. Oh no, he's using it too dark. Somebody help me. You guys help me. So we'll change. Let's see, what would be a good different color? How about sky blue? Yeah. Okay, so we'll do number 5. And so far, how's the board look? Is this maybe a little cleaner than when I'm up here, or is it okay? I know these markers always run out on me, so it's kind of nice having lots of ink on the marker. Okay, so here's this. What if we had x to the 4th over x to the 4th? Now, how's that different than anything else we've done? It's all the same, so it should be 1. So that's sure. Yeah, it would cancel it out and it would be 1. But let's use our properties of exponents as well. What would the property of exponent we would use with this particular one? Well, what do we do with the exponents? Very good. So we're supposed to subtract them. So if we take the top, subtract the bottom, what do we end up getting? Sure looks like 0. So what does that mean x to the 0 has to be? Right. But we got to be careful. It's not just x, because some people think, because x really has an exponent of 1. We talked about that. So this really is, it does have an exponent, it's to the 0, and what it simplifies to is not x, but simply the number 1. Okay. And you could try this with your calculator. Take your calculator, raise anything to the power of 0, and you'll see you'll always get 0. Oh, sorry. You always get 1. So now you're going to have to really try it because you're going to, which one is it? Yeah, anything to the 0 gives you 1. It doesn't give you 0. This begs to differ, one question, and this is more math theory type stuff, but I do want you to get into it. Some of you may get there. So what would you think is 0 to the 0 power? Some people think it should be 0. Some people think it should be 1. And you're both right at the same time, but it can't be two different answers, right? There's a guy by the name of Ramanujan. He was from India. He died young, I think 23 or 33, something. Either age is young, but he was a great mathematician. He had a notebook. There's like over 200 mathematicians in the world working off of his notebooks because he did some mathematical stuff that is correct, but nobody knows how he did what he did. And when he was a young kid, he asked his teachers about this. Should it be 1? Should it be 0? Should it be infinity? And they said, don't ask us, because it's called the indeterminate form. Because yes, 0, anything, if you put any exponent on 0, you get 0. 0 to the 1 is 0. 0 to the million is 0. Because it's 0 times 0 times 0, right? But this weird thing happens when you put, and even 0 to the negative 1 becomes 0. But if you put 0 to the 0, if we call that 0, then it breaks this rule of anything to the 0 is 1. And so what do we do in math? We just say, we call that the indeterminate form. Don't ask us. No, don't ask, don't tell type thing. We can't really explain it. We don't really know. But it's one of those things where if we make the wrong choice, the universe falls apart, at least the universe of math. So it's one of those things where is a big question mark. I think it's probably infinity. I don't know. But you could think about it all day long. These are one of those, math has these little things in it. So and don't worry, it won't be on the test. Or maybe I'll do an extra credit. We'll see. Just to see. But if I do, I'll definitely let you know here. I guess I forgot one thing since we're going we went with this route, right? Because a number of you are here, but some people aren't. What do we usually, we have our word of the day, right? Which we didn't have, so we better put it up here before I go too much further. What should be our word of the day?
Pizza.
Pizza. Sure. Maybe that's what 0 to the 0 is. It's a slice of pizza. So that'll be our word. So look for it. That'll be the way you verify your attendance. And I'll also probably put it on the last slide just to make sure everybody got it. I spell it right? It doesn't look right. It was okay. Maybe because of the way I crossed my Z's. Okay, so those are the basic concepts we need, except actually we need one more set of sort of things. And it's actually just one more property, but these are what we're going to work with. And then we'll spend about the next half hour. And notice a new page has been created. I should be able to save that last one and we'll see. What happens if I have something like this? Okay, so this is the distributive property, and that's so the 3 has to multiply by both parts. So this should give us 3 times x, which is 3x, 3 times 4, which is 12. Does that make sense? Okay, so far so good. Okay. What if I had, so we'll do this just sort of example A. What if I had, say, 3x squared times 2x to the third plus 3x minus 5. Okay. So how does the distribution part look like? What do we just distribute the x squared, or do we just distribute the 3? Or the whole thing? Okay, so this whole term is going to distribute again to each of the terms inside. And I think in 90 they do talk a little bit about terms and polynomials and such. So just to make it a little clearer, 3x squared is going to distribute to each of the terms. And again, they'll have a few examples for us to do on these as well. I'm kind of doing them as we go. And so for each of the terms now, we need to use our properties of exponents, right? So how do we do this one? What's happening between the 3 and the x squared? Multiplication. What's happening between the 2 and the x to the third?
Also.
So it's 4 things all multiplied. What's nice about multiplication? You can do it in any order, right? So couldn't we just take the 3 times the 2 first? Yes. And then we've got x squared times x to the third. Okay, so what's 3 times 2? 6. No trick there. And then x squared times x to the third. We do what with the exponents? Add them. So that'll give us x to the 5th. In the future, you'll probably just look at it and say, well, 2 times 3 is 6. add the exponents and go. But what I wanted you to remember, if you're like me, one of the mistakes I sort of like to make is when I'm adding the exponents, I might end up multiplying because I just multiplied 3 times 2 and I got 6. And so I might be tempted to write down 6 for the exponent 2 just because even though I know I'm supposed to add them, maybe I made that mistake or maybe I forgot or something. But notice this is one of the hard parts of algebra is oftentimes we have you doing two sort of separate things at the same time. So yes, we are multiplying. When we multiply numbers, we multiply them. But when we multiply things with exponents, we actually add the exponents. So you got to take that time to let your brain take a shift in gears. Okay. So, and then maybe these ones will go a little bit quicker. So what are we going to get out of 3x squared times 3x to the 1?
9x.
Good. 9x to the third. 2 plus 1 gives us the 3. Okay. And then the last part gives us 5 times 3. So that gives us 15. And then the x to the square doesn't combine really with anything. And if you want to, this is a place where I can point out that really every term actually has an exponent. This 5, what kind of variable does it have on it? It really has x to the 0 power. Now, it's kind of weird to think about, but I want to stretch your mind a little bit. In algebra, there really is always this x to the 0, right? And 2 plus 0 is still 2. Kind of a weird thing to look at, but it's good to stretch your ways of thinking of things. And that's why I find this math is sometimes it's just the symbols look different. The concepts are there. You could understand, yeah, 5 times 1 is 5. But I want to start writing x to the 0 where we see 1 because I can do it. X to the 0 is 1. No matter what x is, unless x is 0, right? There's that one case. Okay, so there's that. And then there's one more thing we're going to look at, and then we're ready to look at all the examples. Does anyone know what I'm going to do next? Yes. So we won't get too complicated. But when we've got a binomial times a binomial, would it make sense that we have to distribute twice? Or that everything in the first term has to distribute to everything in the second? So what this ends up looking like, and again we'll do. It really is a distributive property. It's two applications of the distributive property. So you could, some of them really labor it. They take this first one, distribute it to the second, and then you distribute again. I like to just say, well, let's just distribute this. That's the first. That's the outer. So that's part of, if you've thought of it, FOIL, first, outer, and then we need to do the inner. The inner ones are the 2 in the middle, and then we do the last, and 4 times 3. So the first one times both of the second one times both of those. So x times x gives us x squared. X times -3, -3x. And you could write it as x times -3, but it's just standard to switch it. 4 times x, +4x. And then 4 times -3, -12. And then, oops, one last step. What's there left to do? Are we done? Okay, good. Combine like terms. So these two things at the middle can combine, so we get x squared. What's that going to be? 7x? No. Just x. +4 -3, so 1x or just x. But it's positive 1x -12. And that's all we can do with it. So we didn't directly talk about adding things with variables and exponents, but they have to be like terms in order to add them. And when they're not like terms, we can't do anything with them, so they remain. And I think that's one of the things we'll look at a few examples now, and we'll be halfway through lesson 2. And then Wednesday, we'll take a look at something called combination of functions, which is to take a whole function, add them, subtract them, multiply them, and divide them. And it's really just an application of what we're doing right here, right now. Okay, it's nothing any harder than this, but the symbols add a little bit of complexity to it. So I think it'll be good that we do a few examples here on these, and then we'll take a look at the other ones on Wednesday. Let's come here. Oops. Oh, forget. I have to switch to cursor mode. We're in lesson 2, right? I think we are. Okay, so we'll go to lesson 2. And I'm going to go to the workbook pages rather than go to the online homework. And that's the media examples. I'm going to get us down to the practice problems. So if you keep coming to the end, oops. Mini lesson workbook pages. Oh, here they are. Okay. So now let me go back to pencil mode. Now I can use a darker color. So we'll just simplify a few of these. What would x squared to the third power end up looking like?
Squared or 2x?
Oh, sorry, 2x. Take a look at this.
2x times 2x times 2x.
Excellent. Let's expand it out, because otherwise, because I'll see people put this as 2x to the third, but it really is, yes, 2x times 2x, because it's everything in that parentheses expanded out. So when you look at it this way, what does it end up being? Because what is 2x? Yes, it's 2 times 2 times 2. So 2 times 2 is 4. 2 times 4 is 8. So be careful, because this is where it gets confusing. You're going to tend to maybe want to add things when they should be multiplying, and multiplying things when they're supposed to be added. I have the same problem. And then x, there's 3 of them, so it's x to the third. That's it. That's all we can do. Okay. How about b? Does that square also apply to the 5?
No.
No. So parentheses kind of divide things. So what's going to happen here? Could we? What are we doing with? It's a good question, and I've seen it done. But what has happened? What are we doing with that 5? What's the operation? We're timesing it, and order of operations tells us who's got more importance. Who do we do first? Exponents. So we can't distribute it until we take care of the exponent. So exponents always are kind of like, you got to take care of me first. Okay. So we take care of the exponent, and what's that going to give us for this part? Good. 3n times 3n, which becomes 9n squared. And then now we can take that 5. Now this is also a place where people will say, okay, so I'm going to now distribute this 5. But why don't I call this thing distributing the 5. Why doesn't the 5 multiply by the 9 and the n? When we use the word distributing, we're taking multiplication over addition or subtraction. But when we are taking multiplication on multiplication, when we have three numbers all multiplied together, we multiply the first two and then take that result and multiply it by the third, so we get 60. Okay. But we don't take 5 times 4 and 5 times 3, because it multiplication, even if we were to group it this way, then if we say, oh, we'll put a parentheses there, we could take 4 times 3 first, which is 12, and then multiply by 5, we still get 60. But it's not the distribution property. The distributing property comes up because when we have a variable, we can't add in here, and so we want to see what, we're kind of basically trying to do the multiplication before we do the addition, because when a variable's in here, we can't be done. But if there's not a variable, 4 plus 3 is 7. So that gives us 35, okay? Which is going to give us the same, if you distribute here, you get 20 plus 15, which is also 35. So just be careful. Multiplication distributes over addition, but multiplication doesn't distribute over itself. Okay. But I see that as a common error, is you'll multiply it out twice. So here we should just end up with 45 n squared. Make sense? Sort of? Okay. How about C?
I thought that because 5 has no exponent, it will multiply with 9.
Because we're multiplying, you can. We could not add it. If it was 5 plus 9n squared, we're done. But when we're multiplying, they are sort of the same base. It's a good, yeah, so 9n squared is really 9 times n squared. And so these are three things multiplied together. The 5 and the 9 are numbers, so we can multiply them. Good questions. These are all the types of things. We'll start working with them later on, but if you have some misunderstandings at this point, that's oftentimes where it causes problems later on. Good. So far, so good? Okay. How about this one? What's the property we're going to use to combine these guys? Multiplication. What do we do with the exponents? Add them all together. And see, they're all the same base. So it's 3 plus 7 plus 1. Good. So that should give us y to the 11th power. And again, if you struggle with these, or if it doesn't quite feel right, try expanding each of them. And I've had students do this, even like y to the 21st power, they'll write out 25 y's or whatever needs to be done. But then you can actually count it. So you could count the 3 y's, the 7 y's, the 1 y. Oh, there's 11 of them. Yes. So we could do that. So I'll put a note here. Y, and then 7 of them. We'll make a mess. And then there. So here's 3. Here's 7. Here's 1. Add them together, and you get the 11. Okay, a little bit getting into what happens with when we have a negative inside and we're using an exponent. Okay, so we'll just kind of look at this property. What would be your approach to doing this one? What does the exponent of 3 mean? Okay. Rewrite it as what?
-2 and then x2. I mean,
Isn't it just 3 of these guys?
Yes.
Good. So when you said 8, you were sort of correct, but it'll be a minus 8 because there's an even, so a negative and negative make positive. One more negative makes it turn back to negative. So, right, negative 8 x to the third. And another way you could think of it is that 3, actually the exponent does distribute over multiplication. So another way to think of this is this negative 2 to the third, x to the third. You could do it this way, and sometimes it's going to be easier. We'll get some more complicated ones, but both approaches get you to negative 8 x to the third. And one of the things you'll focus on is if the exponent is odd, and you've got a negative inside, it'll still be negative because you'll have an odd number of negatives, right? Even number of negatives makes something positive because it's multiplication. Okay, let's, while we're on the subject, let's go ahead and look at f. So let's raise the second power. So what's that going to give us? So it'll give us negative 2 x to the fifth times negative 2 x to the fifth. And the results? 4x, 2 times 2 is 4. Negative times a negative is positive. Good. And x to the 10th, because when we're multiplying, we add exponents. Good. And if you come back the other way, this would have been this exponent of 2 times 5. 2 times 5 is also 10. So you'll start seeing those connections and multiple ways of thinking your way through things. Okay. You want to do E or shall we skip it? Does it look okay? Give you something to practice. Sure. Well, what would it be? What does this parentheses mean? Just really means multiply, so we could kind of take them off. So what do we do when we're just kind of multiplying? Can we multiply the numbers? Yes. 8 times 5 is 40. And then w times w to the third, w to the fourth. Add the exponents. So there's a little 1 on here. So 1 plus 3, w to the fourth. And that's all there is to that one. So the parentheses would just maybe overkill. Okay. Let's see. Let me do K. Oh. Let's see, let me save this one. And then I can scroll down. Okay, good. So we've got a couple other examples. We won't, but again, we don't really, we'll work a few of them, but you have the answers to these, I believe, or do you? Do you know? That's what I thought. They should be. We'll look. I make the assumption. If not, I can find them somewhere, or we'll get them to you. But I think you have them. You should have them. If you don't, I'll get them for you. Let's go with. Let's switch divided. Okay. So what do we do here? Okay. Okay, the ones, yeah. So we'll get to those, but. Okay. So good. So let's look at this. This is really just 5 times x, 8 times x, and we're multiplying them. So it's really just 5 times 8 times x to a fractional exponent, which we really haven't talked about what that is, but I don't know if we ever will.
You do that since they have different denominators?
Good question. When we multiply things with exponents, what do we do with the exponents? Good. And if we add fractions, what do we need? We need a common denominator. Okay. So this one is simply going to become 40 x to some power. And what I'm going to do is what's going to happen here, I'm going to need more room. So I'm going to take 2/3 plus 1/5. So these are the types of problems I call kind of obnoxious, because it's hard because they gave us some fractions that are not easy to deal with. If this was 2 and 3, we just 2 plus 3 is 5, we're done, right? But this is making it complicated. These are the ones you can kind of skip if you'd like, but they're also just sort of put here to remind you about fractions. It's just whenever we have anything with the same base, when we multiply it, we add the exponents, okay? The exponents are fractions, so we have to deal with it. What's our common denominator? 15, good. So to make 3 turn into 15, I got to multiply it by 5, right? And so I multiply both the top and the bottom by 5, because that's 5 over 5 is actually 1. When I multiply by 1, I don't change any values. So these are, and then to turn 5 into 15, I have to multiply by 3. So I multiply the top and the bottom by 3, which is really like multiplying by 1. Okay, so here I get 5 times 2 is 10. 5 times 3 is 15. 3 times 1 is 3. 5 times 3 is 15. Now I can add these together. 13 fifteenths. Good. So it's just kind of, yeah. And sometimes in math, that's what makes things difficult. It's the concepts really aren't anything, we understood the concept already. It's just now they gave us a particular example that was difficult to deal with. So we'll put 13 fifteenths here, which doesn't reduce, and 13 fifteenths. Okay.
The only answers I found back to the book that you tried.
That's what I was thinking. And it's my fault. I think I told my class last semester I'll find those answers, and I got busy. I don't think I ever did, so now it's going to catch up with me, and I'll find those answers for you. Maybe I did and posted them somewhere else. I know I had them at one time, so I will dig up where those answers to these practice problems are, and I'll get them posted right next to them. In fact, I'm sure I did. Maybe I did that. Anyway, I'll figure out where they are, and I'll get them posted. Okay. Okay. And then as you see here, this is sort of towards the end. We've got ones with multiple steps, different type of distribution. Do we want to take a look at A, B, C, or D? Or do you want to move on to something more complicated? Which one? They're all easy? That's good. That's good. When they become easy. If they're not easy, then we'll practice them, right? So let me do this. Let me save this page. Oops. Oh, see, I can go backwards and forwards, but that's the one thing with the notes. It doesn't remember what was on the screen. So let me take one. I think they have one in here, which is a binomial times a trinomial. Let's see if they did that. Yes. Okay. There's two I want to take a look at here, and I think that should be able to get us the rest of the way. So we'll just take a few more minutes and let's see. Let's go with dark green. Okay. So let's take a look at D now. What does that square mean? So do we distribute it to both?
Give each value that exponent, right? Basically 2x and 8 for both of them.
If it was multiplication, we would. And remember, with distributing, you can really only distribute over something that's one step down. So if we got an exponent, we can distribute it over multiplication, but we can't distribute it over addition or subtraction because that's two steps down. Okay. But what can we do? Well, what does an exponent mean? It means it's whatever it's on times itself that many times. So if this was a 3, we'd multiply it out 3 times. But since it's a 2, we just multiply it out twice. Okay. So that's the first part, is when we see these exponents, it just means repeated multiplication. And I'll come to that. We won't actually do this one because it's, or maybe we will if you ask. It just means repeated multiplication. So it means q minus 2 times itself 3 times. And so for this one, actually, we won't do it, but if you wanted to, you FOIL out the first one, and then when you get your answer, you FOIL it out by the next one. And what we're going to do is we're going to take a look at E to see what you do when you've got something with 2 terms times something with 3 terms. I've got maybe a little nicer way of doing it. Okay. And so then now what do? This is what we call the distribution, right? And we do FOIL because we distribute everything in the first. So the 2x times 2x, 2x times negative 4, and then we take the negative 4 times the 2x, negative 4 times negative 4. So everything in the first times everything in the second, and so forth and so on. And so 2x times 2x, 4x squared, 2x times negative 4, negative 8x, okay. Negative 4 times 2x, another negative 8x, and then negative 4 times negative 4, positive 16. And again, remember to come back and add the like terms that are in the middle. 4x squared, negative and negative. When we're subtracting, it just becomes more negative. This really becomes negative 16x. Now, another mistake I'll see people do is they'll make this x squared because they think of 2x's, but when we're adding like terms, we don't change the variable parts. So there's a lot of technical stuff in here. And then there's just the plus 16 that tags on at the end. Okay. Does that kind of make sense? Okay, and it does take some practice, and that's what these here are here for, is practice problems. And yeah.
Since there's 2 x's with the, since there's 8 negative 8x and then 8x, how can it be negative 16 squared?
Because we're not multiplying. If we were multiplying, then it'll be x times x becomes x squared, right? But x plus x, we do this when we're adding, we're looking for like terms. All we're doing is adding the coefficients in front, the numbers in front. So this gives us 2x, still to the first power. Okay. And good question, that we had 3, say x squared plus 5x, can we do anything with this? We can't add because they're not like terms. Okay, if they're not like terms. So it's good questions. These are all good ones because those are the ones that, you know, start throwing you off. And good. Okay, so let's take a look at this last one. What do we need to do with this one? It's really distribute everything in the first to everything in the last. But now there's 3 terms to distribute to. And this one, multiply 3 times. And what you find out is it can get very messy very quickly. So one of the ways I like to do this is rewrite it vertically, or I guess x squared plus x minus 5, and then put the x minus 4 underneath, and sort of multiply it the way maybe we were taught with multi-digit multiplication. And then you just kind of do this like maybe we did back in 4th or 5th grade with numbers, right? Negative 4 times 5, a positive 20. So I multiplied those two. Then I take the negative 4 times x, and what's that going to give me? Good, so negative 4x, and then the negative 4 times x squared, and that will give me us negative 4x squared. Okay, drop down a line, and then usually when you're doing this, you indent a space. You don't have to, but you'll find that that helps. You take x times negative 5, negative 5x, x times x plus x squared, and then finally x times x squared. That's a 2 plus a 1, should give us to the third. And notice by doing it this way, the like terms are lined up underneath each other, which is kind of a nice thing to happen. If you do it horizontally, you'll get the same thing, but it's all on one line, and then you got to go back and figure out which ones are like terms. We add now nothing what goes with the 20, negative 4, negative 5, they both have the x, so that's x there, and negative 4 and negative 5 become negative 9. Negative 4 combined with a positive 1, negative 3, x squared. And notice the variable part doesn't change because we're combining by addition or subtraction, however you want to think of it. But like terms stay like terms. And then the final is x to the third. And that's it. So as you practice these, this will be in the homework as well. The online homework will have you do these. Do about half the way. You'll see you'll start getting into something where they start adding functions. Save those for Wednesday. Or if you want to do them, that's fine too. You might not find them too hard, but that's what we're going to focus on Wednesday after you practice some of these. The other thing is when we get to the lesson on quadratics, there is a lesson in there that deals with factoring. What factoring is say for D, they start here with this as the question and they ask you to go backwards to this. So we're going to take some quadratics like this, factor them back, and then this becomes, instead of being the question, is the answer. So as you work through these, the more you pay attention to the process, when we go backwards, it'll make more sense. Don't think too much about it right now, but just try to watch the process and get a little bit of practice so that when we get, I think it's like lesson 7. So it's down the road. Maybe it's 6. I can't remember, but it's quadratics. It's down the road. We'll basically be doing the same thing, but we're doing it backwards. Okay, which is harder because we lose some of the evidence. This, we know, just multiply things out. It's pretty straightforward, but we'll get there. Okay. Any other questions or things that you think of that are in this section that you'd like to take a look at? Good. Everything working out so far smoothly? You tell me if it wasn't. Probably not, but just got to practice. Exactly. That's what it is it just kind of seeing these things. Now remember the videos, they're posted. Easiest way maybe is go into Canvas, you can get on them. Or if you subscribe to the YouTube channel, you can go back and dig through them. I try to title everything Math 121. So if you do a search on Math 121, only that stuff should come up. And my other classes, I put it by a course number. I try to get them in there. If something's difficult to find, just send me an email. I'll send you a direct link. And it'll also help me because sometimes I forget to post things in a certain way. And I make sure it's all accessible to you. So awesome. So we'll end the live stream at this point. So those of you who have been attending class through the internet, thanks. See you later. And those that are still here, you're welcome to hang out and we'll work through some together or whatever you need to do.